In this lecture we will discuss the temperature adjustment functions of the sample conditioning panel. If the sample is too hot to be measured by the analyzer in its original temperature, we use sample cooler to cool down the sample to the appropriate temperature compatible to the analyzer temperature specifications. Sample coolers are small shell and tube heat exchangers that are used to cool the sample from a process stream to the required temperature conditions for safe and immediate analysis. It is one of the most critical components of a sampling system suitable for most applications in liquid, gas or steam process. The sample to be cooled flows through the tube side of the cooler, and the cooling fluid, usually water, flows through the shell side. The cooled sample then is taken to analyzer. In this slide we will talk about the sample cooler basic design. Mainly sample cooler is constructed of a single, one-piece heat transfer tube, wound as a coil and housed in a cylindrical container known as shell. The shell is mounted through flanged connections and it can be removed without disturbing sample lines. The sample cooler should be installed as close as possible to the system take-off point and installed at a height to facilitate convenient operation. Also, the sample cooler should be mounted in the vertical position. Here are some must-have features or characteristics of a good sample cooler. Safe and accurate sampling. High efficiency, meaning that the outlet temperature to be very close to what is desired. Designed to handle high pressure and high temperature samples. No welded joints in coil. A complete single-piece coil assures trouble-free operations with no risks of failure of joints inside the shell. Corrosion-resistant materials. Counter-current flow to achieve very close temperature approach of the sample to the cooling fluid. Cooling fluid requirement must be minimum. Also, size must be small and compact. This makes the mounting of sample cooler easy and minimize the cooling fluid utilization. Facilitation of routine on-site maintenance easily, meaning that the coils can be cleaned or replaced, if required, in an easy way. Some designs have inbuilt safety relief valve to prevent accidents in the field, in case of an unlikely event of coil failure. Self-draining design to eliminate sample retention. Meaning that the cooler sample inlet is in the top and sample outlet is in the bottom. Shell must be easily removed without disconnecting the sample lines, for inspection or maintenance purposes. The cooler should cause low pressure drop to the sampling system. If sample coolers are not cleaned periodically, rust from cooling water headers and pipes may accumulate in the cooler shell and cause reduction in the cooler's efficiency or may cause damage to the coils of the sample cooler. Sometimes rust is solid and sticks to the cooler coils, making it very difficult to remove the coil from the shell. To solve this problem, from experience we can use 10% HCl and water to clean any rust or scale in the cooling water tubes and the cooler shell. But what happens if the cooler fails? In most designs the sample cooler is followed by a temperature shutoff valve. The temperature shutoff valve is a fully mechanical valve designed to protect the analyzer and personnel from the damaging effects of excessive sample temperatures. These temperature excursions could be the result of excessive sample flow rates, high cooling water temperatures or momentary loss of cooling water. Also, in many applications, where we use sample line heat tracing, the sampling panel must be also heated to maintain the sample temperature during conditioning in the panel above its dew point, and prevent condensation of the sample or forming liquid droplets that may harm the analyzer or invalidate the analysis. Also, we may need to heat the panel to prevent freezing of the lines and components inside the panel. For those reasons, we use electrical panel heaters, or in some cases we use steam panel heating with a temperature controller to maintain the temperature at the required set point.